Hey guys, welcome back to the next video. In this video, we are going to talk about the layered section. Now that we have set it up our environment and running our Docker using VAS user and running the Docker process as a root user. So this is going to be the thing which we wanted to start up our work in terms of layering. So now that we have already installed an image over here, so which is the hello world image. So if I just run Docker images, you can actually see that hello world image over here. So remember that there is always an option -a, which means or else I can give -all. So which is basically the same, which gives me all kind of information and towards like understanding not just about the image which is referred in a container, but also images which is just generally created. And also it is going to display any kind of images which is part of your Docker installation. So some images like are unused images and dangling images, they call it. The actual word is dangling images. I was just looking for that. So these images is something which you may not see when you type Docker images. So that these images only can be seen with -a. Okay, so in those situations, to remove those dangling images, we can just use prune command here. This Docker prune will remove all those dangling images and unused images which is running on the background. Same goes for in terms of containers as well. We can use the same stuff. In terms of layer also, we can do the same stuff. Now you must ask me like, oh, what? The layers are stored here? Yes, every layer you create on top of each other, that layer is referred to the previous layer. That's how the cache works. The cache works because of layers. So we will talk more in detail about it. The first thing is that you need to create a folder of OPT containers. Now, OPT containers folder is going to have all the containers which you are going to require in this installation. For example, you're going to have your Tomcat Hello World and HTTPD. So these are some folders I've created. Okay. Now, why I wanted to create containers folders and this HTTPD or Hello World or Tomcat folder is because I want to create images for these containers. Okay. So for a container, I need to create an image. So which means that I need to have a folder where I can create my Docker file, put in those related files so that this particular folder can be used for a container when I create an image out of it. As of now, I have only one image. That image is downloaded from the internet and run directly on my container. Right. So now the second image, what I'm going to do is like I'm going to create a layered image. The firstly, I said I'm going to build a base operating system image, and then on top of that I'm going to install certain things. I'll show you that. So let's go to HTTPD and do a LSF and LTR. So now you can see that there are a lot of files here. So let me delete all those files here. So including, I'm not going to delete these 3 files. I'm going to delete this folder as well. So now that I've removed all the files, I'm going to create a file called Docker file. Now this should be the actual name of the file if you want Docker to automatically read stuff from the Docker file. So as I told you, there are 3 options of running a container. First option is to directly run a container which is hosted somewhere else, and then you use the logic in that, but that doesn't make any sense for us because nothing we can use from existing logic. Second option, as I told you, is to build an image, a base operating system, and then on top of that, we install Yum and other stuff, another technologies or softwares which is required for us to work with the application which you are planning to install. And then we are going to install the custom version of HTTP, which I wanted, the correct version which I wanted. And then we are going to send the configuration files there. So these are the stuff we are planning to do. All these activities will take about 6 images, 6 layers, I would say. So each layer we are going to create one file. So I'm going to show you that as well. So let's just start with all these activities. I will explain you in much detail. This video may be a bit longer than expected, so please get a cup of coffee or tea. So this is gonna be little a little longer. And remember to practice this video right after you look at this video once. Do not do both the things at the same time, because sometimes it may not work. I may not get the expected results, so I may have to do it again, or I may have to do it in a different way. So please hold on until I complete it, so that you acquire the full knowledge, and then redo the video, because you will know where is the pitfall, where is the problem, because this video is a troubleshooting video, which means that I will wantedly make mistakes while making the file, so that I can show you how the error looks like. Right, so let's go ahead and do a VI of a Docker file. Now this Docker file is going to have all those instructions which is required for you to execute a container. So now let's open VI Docker file. And then this first one is going to be from an operating system. So here I need to specify an operating system over here, which I need to, or a base operating system, which I need to download. So now here I don't know which operating system I need to download. So let's quit this file. And then what I'm going to do is I'm going to run docker search. And then as I want to install CentOS, I'm going to see what are the CentOS versions available in Docker. So as you can see, there are CentOS versions here, but this is depreciated. So which means that it doesn't even give the version with what it is using. But it has like 7,689 stars here, which means that it is quite popular and it is an official image. Automated means these have some kind of automated package which will execute once you start your CentOS build pack. So this basically is designed for someone who uses this particular tool, Bitnami. So likewise, some applications or some images may have custom usage, and that may be related to that product. Now let's check about the HTTPD. Now we can see that HTTPD has one image, which is official image, which is Apache HTTP server project, and it has 4,621 stars. So which means that this is also popular when you compare with other HTTP versions. So you can see that 24 on CentOS 7, 24 on CentOS 8. Likewise, you have people creating and uploading it. So this is from CentOS itself. So that CentOS is the one who's maintaining it. Now, you must also see the Nginx. Nginx is a far more popular software choice in terms of containerization. So Nginx over here comes with 19,392 stars. So which means that this has more popularity than Apache HTTP server. So this is the official version of Nginx. Again, another thing which you should remember is that this doesn't tell you what version of Nginx it's running on or which operating system. But this should be running with an operating system. It is not serverless. It needs a server to host Nginx on top of it. So you need to have some kind of operating system running on the background, and that should actually have that executed. So the next item I want to show is Ubuntu. Now, Ubuntu, on the other hand, is going to be a little popular as well. As you can see, it has 16,000 stars, and this is a Debian flavor, and it doesn't specify which version of Ubuntu it is. And you can see WebSphere Liberty and Open Liberty is part of the Ubuntu architecture. So we may be installing all these software later point of time. You can see Ubuntu has Nginx as well. So this is Ubuntu. This is Nginx built on top of Ubuntu. That's very clear and straightforward to understand. And there are certain things which is like you can see that it is depreciated. Use Ubuntu instead of this Ubuntu Bootstrap or Upstart. So likewise, it is telling you to use Ubuntu as part of this. So this gives you the complete details. So you can use this option no trunk over here. As I told you before, no trunk is gonna get you the output in terms of full. If you want to read the complete stuff, right? So you can actually read that like this. So you can see that this is Prometheus, this is Kafka, MySQL, Zookeeper, and all those other JRE, so Grafana. So it's all like custom images just already available. So he can see that long-term track maintained by Canocchio. So likewise, you have different people providing you those softwares over here, and they are basically has all the softwares which you need for you to run. So you can see the .NET runtime image also over here as part of your Docker containers. So likewise, you have all the softwares which is required for you to run. So now let's go and search for our software over here, the CentOS one. For this example, we'll use this. So we are taking this Docker image for CentOS Streamline. This is the only Streamline version available here. So let's go and pick that up and let's put it on our Docker file. So here from, I'm going to paste Docker image. So now I'm going to create an image out of this. But before we create this particular layer of image, so we will need to make sure that we are currently on the folder where the Docker file is before we run this build command. Then we will also check in the var lib Docker under the images, under overlay, and then under the layer DB. And then the SHA-256, let's see that we have only one layer right now. And that layer which we have currently, that is for this particular, the hello world at this moment. So when you just do a cat on this layer, let's see what it is saying inside this layer. So layer will have some kind of a image. So it's a directory. So within that you have the size differentiates the cache ID, all those information. So you can see that the cache ID or the JSON, you can see it over here. So the layers will have all these information. So as of now, you have only one layer. So that's basically where the caches will be created. So now, as we are going to use a different image, so it's not going to use that layer or a cache. So to build a Docker, so Docker image, so you just put Docker and then image build -t as in going to be the name of your image. It's going to be httpd_1. That's the name of my image. And then where, so if you just put enter, it's going to throw error. So you need to specify where exactly you need to fetch that automation file, which is Docker file. So you can give -f and then you can give the complete location of it, but then you can also give dot if you're on the right directory where the Docker file is. So when you do that, it's going to start to build, which means that's going to download the Docker file right now. As you can see it on the screen, it is downloading the Docker file. And then now it is verifying the SHA, all these layers of items with this SHA verification. And then basically downloads the files over here. And then it starts extracting these files. And then you can see that it is exporting the layers and it is exporting the images over here and then writing the image. So now where did this image go? It went over here to OPT. Where the Docker, and under the Docker images, overlay, image DB. And then when you go inside the content, you can see that content over here. So you have two contents over here, 6AE97, you can see this one, and this one is the same. So the first other content which we have over there was for VAS user, and we have changed the username. That's okay. You can run it as root user, it doesn't matter. We can always do a change owner and change the ownership. And this one is basically the hello world, hello image, hello world image. Now, you can also check the layers over here, which is over here, layers, SHA, and then you can see all the layers over here. So these are the layers which was created in terms of while creating this content. So you saw that there are two layers created right now. So this is what happens, and each layer will refer to each other. So this layer will refer to this one because they are all related and linked between each other. So now that you understood that, where the layers and images are kept, so the next item is like when we check the Docker images, you can see that there are two images over here. Now this layer has only the installation of the core operating system or the base operating system. Once this is completed, what you can do is like you can go ahead. Oh yeah, so look at this. You can see the size over here, difference in the size. So you see the Hello World is a very basic program when compared with the HTTP one, which install an operating system on top of it. Now we're going to complicate it even more by doing a little more activities. Like for example, we have to use for HTTP, you need API and API util, and then you also need the yum config manager. So we need to install that. But remember that the base operating system doesn't even have the repository file. So what you have in etc yum .repo d, right? So these files like CentOS and CentOS add-ons also it won't have. So if you run yum on that, it won't work because it doesn't know about any repository. So it is vital for us to copy this CentOS star to your folder where you are and where the Docker file is located. Now what we're going to do is like as a second image while we are creating it, we are going to send these two files into that image. Okay, so that's what we are going to do right now. So open the Docker file and then say copy. What it needs to copy? It needs to copy CentOS star to etc yum.repo.d. So if you're not sure if this is correct, because I'm not sure if this is correct, CentOS star to etc yum.repo.d. So you take this, copy this one, because it's always good to compare it once to see if all these are rightly available, right? So let's save and quit this file and let's run this file. So if you notice that, you would have noticed that that the command is not going to work, but I want to show you that. So I'm building the second image with just this CentOS and CentOS add-on copied to the remote server. So let's just execute this. So now you can see that it's rather than downloading it from the internet or network, it is using the same image, as in like it is using the image of 4A, 4C. This is the layer, which if you see the layer output, how many layers we have seen the layers, right? So it has created a new layer over here by using the stream image 4A, 4C. So let's see the images over here once. So likewise, it has created a new image as well over here, 99. So this is the one, images over here. It has created a new layer here, and it has created a new image over here. Now this image is basically 99BC, right? So the same image is what will be displayed as part of your display images, Docker images, right? So you can see 99BC 81. So actual full name is there. You can give -no -trunk, and then you can actually get the full name of this image, which will match this location as well. So likewise, you have created another image. Now this image will have not just the base operating system, but base operating system plus those two files copied over. Now let's update our Docker file with more information. Like for example, let's ask Docker to run a command. So now we have executed from image, copy this files. Oh, okay. I'm sorry. I think the image. oh, okay. So it tried to copy, but it didn't actually validate it. So it just tried to copy it, and it created an image without copying anything. Okay, so now that's the problem. So now let's try to use a command called add. So let's try to use the command called add over here. Let's quit this file. Now I know that there is a mistake in the command. So now let's just try to create a third image. So now you can see that if you make a error in the file name, it doesn't worry about it. But if you make a mistake in terms of your syntax, right, it will immediately throw up the error saying that you mean add. So it can also guess what could be the actual parameter you are looking for and how it basically is done. So now let's do the correct one and let's just execute on top of the image 2. So now what we are doing is like we are redoing the image 2. Now image 2 is redoing it by adding this. So till here it is using from the cached image, and here it is going to use it from the actual Docker file. So now it has created another image. You can see that right now. It will come different ways. So your old image is become none. So which means that you have overwritten this particular old image with the new image. You can go ahead and remove this image with RMI because we don't need this image anymore. So when I do that, then you can see that that image is gone. So now that we have created this, let's open Docker file. Let's ask it to run. So what we are asking it to run is yum-y install. And then I'm asking it to install what I wanted to install. I wanted to install yum utils, APR util. So there's 3 commands, but when you install this, you cannot actually identify the difference. So what I'm going to do is like I'm going to ask it to also do one more activity of creating a directory. So I'm going to ask it to do 3 activities over here. One is to create a directory, make directory -p, and then opt content example, as I've given -p, it will create all these folders together, and then it will add the content.tar file, and it will, let's say that it will copy httpd.tar file into this. What is the difference between add and copy? That must be your question. Well, add meaning that it is going to not just copy it, but it will extract it. For example, in this opt content, it will extract this content.tar file in this location. Okay, but if it's a file, it will copy the file. What copy does is copy will blindly copy this tar file into this location. So when I open this particular image, the HTTP3 which I'm going to create, I will see this folder will have, and this folder will have this content extracted, which means that there will be a file inside this folder called index.html, and in this folder I will find this http.tar file, tar.gz file. So this file will be copied, but this tar file will be extracted here. That is what I wanted to see when I execute it. So as you can see over here, I'm using CentOS. So this is the first image, second image, and after third image, I will see all these activities. Okay, so let's have a look at this by saving and quitting this file, and then executing the build for number 3. Now, when I execute it, you will see this particular action item. It will be also considered as cached because it will be retrieving from the cache location and it will start executing that cache location. So you will see that right now. So you can see that it has come to cached over here. Until the point number 2, it is cached, but it has 6 action item over here. it is in the third action item, which is the third line of our coding, saying that run yum install. So it is doing the yum installation over here in this location. So you can see that it has started downloading the packages. There are 12 packages required, it seems, and it is updating all the packages. And then it is just adding as in extracting and copying. Okay, so now when I open this image http_third, I will see these activities done. The next thing is that now you will see the layers and the images will have increased. So if I go for images, you can see that it has created one more image, A to C. That one, it has created a new image. And you can see that in layers, you will see extra layers over here coming up. Now, these extra layers are the layers which you just created right now. So all these layers will be utilized as a cache. Next time when you execute one more action on top of this, it will recreate it. Now, what I'm going to do is like I'm going to open Docker file. Now, what will happen, what will I do here is that instead of copy, I'm giving add over here. Now, what will happen to my image when I open the HTTPD4, which is the latest one, which I'm going to do that, you will not find the zip file in this location. You will find the extracted HTTP file folder in this location, and you won't find any tar.gz, because what it has done from the previous image of layered image, it's adding another image on top of that, which has this configuration. Okay, so let's see that also. Let's execute this layer as layer 4. As of now, we are not looking at it. We will get to look at it. Hold on. So now here, until this cached, it went till the 5 out of 6. And then it just redid the entire thing over here, which means that it added a new layer on top of it. And then it created a new image over here. So let's just do Docker images. And then you see that these are the different ones. So what I'm going to do is like I'm going to run Docker, run with IT, as in like I want to choose the image name. And then I do a bash. Now what is bash? Here is the command which I'm going to execute. Now these commands can be part of the script as well. For example, you can run some command when the Docker build is running. So for example, this Docker file can have from, and then it can have add copy, and it will have one more thing called add copy and then run. So all these activities will happen while creating the image. But there is a word called CMD. When you give CMD and some values to that CMD, it will only be executed when you run the container, when you run the image in a container. Okay, now that won't be visible. You don't have to be in that folder. I can be in any folder because that command will be hard coded in your image. Okay, so whenever you run Docker image in a container, that command will be running for sure. You don't have to worry about running the command. So that is the use of the command feature. Now, I'm not doing any command at this moment, but I'm just telling you that there is something like that. We will look at it a little later. So now let's just run this Docker run IT HTTP1 bash. Now this is going to get into the bash mode. Now you are inside the container. So if you have another console, you can just open another console and you can do a ps-ef Docker. You can see that you are actually running the Docker process as bash user. You see that. And when you do Docker ps, you can see that one container is in use. For last 25 seconds, it has created. Status is 24. It's a sleepy hover. It's a name it has given randomly. Ignore that. So what is this container is working with? It is working with the bash TTY. Okay. So now you are in the bash shell. So you can see that this is the shell of the, this is the slash or root folder of your container. Okay, so now I'm in the base image. If I go to etc yum.repository, you'll not find anything here. Wait, hold on a second. Which one I'm in? HTTPD1. Okay, maybe it has the default files. So let's not compare this one. So let's just go to HTTP2 and then go to etc yum.repository. It should be there as well because it's anywhere there. So this doesn't matter. So let's go to HTTP3. But one thing I want to show you is like I have to go to OPT, right? So you will see that there's no file and folder, and you will see yum is the only command. There is no -config manager. There's no command like that. So we will use that as an example rather than that one, because sometimes a repository might be there. So you cannot determine things on that. So m command is not, m config manager is not there. And of course, API wouldn't be there because there's no folder created. Now let's go to the HTTPD3. Now what we did in HTTPD3, if you remember, we ran the m command. That's the one. And then we also make directory. We also copy the content directory, as in like we added the content.tar file, which means that you should have a file inside example, and you should have in the OPT folder, you should have the http.tar file. Okay, it should not be unzipped because in the 4 we unzipped it. Okay, both the tar files. So let's see about that if it's there. So I'm in the OPT folder. Let's do the lsf and ltr, and you can see that you have the tar.gz because we use copy command for this. And then when you go to content folder, you can see the example, and you see a file here because it would have extracted the content over here, and that's the file index.html. Now you may say, how did this file come? Because the content.tar file had index.html. Okay, so now Control D for exit, or you can type exit and come back to your original shell. And then you execute the number 4. Now what you will find in the number 4, you will find the same HTML file, the same everything, but you will also have the HTTP folder rather than http.tar.gz. And then your M and everything should be installed. I will show you that as well. So if you just go to OPT, you can see that the tar file is not there because we used add command rather than copy command. So you have the folder. If you go to content examples, you will see the index.html. And also you will have yum-config manager. Likewise, you have so many options over here, and API is also installed as part of this. Okay, so you can run the OPT httpd bin apache ctl-t or -v. So now this Apache is working. Why? Because Apache, this APR is installed. Without APR and APR utils, this command wouldn't have worked. So you now know that you have different versions of your HTTP on your Docker image, and each version carries a different layer output. So the more layers you're going to add, you can see that the file size is automatically increasing, making it heavier and heavier because you're doing more customization to your image. So this can be considered as version 1, 2, 3, 4, and each version will be having a different property. And all you have to do is you need to update the Docker file for whatever the activities you need. Now, on the other hand, I just want to give you an introduction to Docker Compose. Now, Compose is going to help you to streamline these options. Now, as of now, how many images are you creating, or how many servers in an image you are creating? One server in an image. But if you want to create multiple servers in a big architecture for your Docker, yes, and you want to use more interactive language like YAML, so that's where the Docker Compose is coming into the picture, where you will be using Docker Compose to have multi-environment configuration, YAML-based configuration, which is much easier than this. So likewise, you can define a lot of parameters in Docker Compose. That is the use of Docker Compose. When we talk about, when we really have the time to talk about it, then we will talk about Docker Compose. So pretty much I wanted to show you the layer. That's what I showed you. I hope it was helpful for you to understand the different layers in your Docker file system and your Docker containers. Thanks again for watching this video. I'll see you on the next one.